Hello and welcome to yet another edition of C++ programming fast track for games or something or other. Today we are going to look at serialization. That means reading content from a file and creating classes, and vice versa, having classes or data and then serializing that to a file and reading it back is called deserializing. Today we have Alex Stained, also known as We Are Undoomed. Great. Chad, Joey, Lynn, and Ted Troit joining today. Might get a few more people joining a little bit later, but so far it's a good turnout. And let's just, talk about the topic at hand. Before we get started, I always forget, but does anybody have a question about the intake process or anything else?
No, I can just say that I'm scared for tomorrow, but I'm also excited.
Is it online for you or?
Yeah, because
Okay.
I can't fly out to the Netherlands, sadly, because I
Yeah.
have exams
You'll be fine. Do you know if you're in the morning or in the afternoon?
in the morning,
Okay, then
which
you're
is fine.
probably, yeah. You'll do fine.
Okay.
Anyone else? Okay, no, then we'll get right into it. Let's see. I got a few pages here. So there has been some chatter in the chats about serializing data to a file. Somebody mentioned that they're using JSON for data serialization. So we have this library, and I think we're going to try to integrate this library into a small C++ project, and just see how we can like create just some saved data structures or something, and then try to serialize them to a file, and then we'll also try to read them in from a file. And generally, we don't actually, write serialized data by hand, especially when you're talking about save game data. You create your data structures in C++. Then you use the serializing tool to serialize it to disk, and you read the data in. And you don't really write it by hand and then adjust the classes to match it. It's not really reliable, but we'll see how that workflow works. And this is quite a few files in this thing, but I don't think we need all of them. But we'll take a look at JSON parsing, and then I also want to take a look at this library. It's called Serial, and Serial is based on the Boost serialization library, which I've used in previous projects. But Boost comes with a lot of extensions. And in case you don't know what Boost is kind of like, which one am I on? I don't want to be here. I want to be on the main page here. But Boost is more like a huge collection of like third-party libraries that, in some cases, end up in the C++ spec or standard, I should say. So serialization hasn't made it into the standard yet, but let's see if we can just search for serialization. What was it called again? Serialization. Not that one. There's a specific library called Serialization Library. And this is another library that you can use. But because of all the dependencies, Boost is not a small library. And if you have to compile Boost for all the different versions, whatever your target tool chain is, whatever, it's very, let's say it's a very not so easy library to work with. There's a lot of dependencies, and it makes your projects pretty big. And including, here's optional, I think that made it to the standard. But including all the header file dependencies, it can also really slow down your compilation time to include such a large library. But we'll see if we can get work with Serial for serialization and JSON. I don't even know how to pronounce this, but nlohmann, yeah, whatever. Nlohmann. Anybody want to try to pronounce that? I don't know. But anyways, it's just JSON for modern C++. Let's call it that. It's probably an acronym for something, but NL the whole man or something like that. Like my name is JP Van Osten, but it's not. Maybe it's NL Ullman. I don't know, or N Lohmann. I don't know. I don't know, man. But okay. So I have set up already a little bit of a C++ project, and what we're going to try to do is we're just going to clone the repo here that we have on GitHub, and then we'll try to just do something with this by purely reading documentation. All right, so first thing, let's clone this thing. So I usually just take the GitHub URL with the .git extension on the end. It doesn't really matter though, because it will figure it out. And off screen here, I'm just going to pull it into another project. D drive projects, and then let's clone this here into a folder called JSON. This shouldn't take too long, I hope. This I can show on the screen, of course, in case you're wondering, what's happening? I can't see what's happening. Oh, thank God, it's still cloning. Didn't miss a thing. All right, so that's it, receiving all the deltas and stuff, and that should be there. And let me just change some things here. Show this on the screen there, JSON. Here we go. Okay, so here's our directory. I don't know if I can kind of make this bigger, whatever. But as you can see, there is a CMake list file. Okay, that means we can use CMake for this. And a CMake file, which is a folder, which is usually like extensions and chisels. So unfortunately, there's no easy way to open the CMake GUI, but we'll just do it by hand. CMake GUI. Sometimes you can right click on a folder and then you have the option to like open in CMake. That would be awesome, but no. Right, so let's make that. That's the code path, right? So that's where the source build is. And then for the build, we'll just put it into JSON build, and then we'll hit this configure button down here. Yeah, the directory doesn't exist. Of course, let's create it. Visual Studio 2022, yes. Default native compilers, yes, please. Everything default. Okay, that should be good. Then if it compiles, yeah, we get a bunch of stuff here, and we have some options. I'm going to leave everything default unless something like testing or something is enabled here. System includes sure. Doesn't look like there's a testing library. Test standards, which I don't know what that even means, but okay. Let's just leave everything on default here. Click configure again. Everything turns white, and now we can click generate, and then we can open it in the project. And it went to my left screen, so hold on. But for this library, because let's see, in the documentation, it says that it's a header-only library, but there is I think there's a, I'm not entirely sure. Maybe we can just try it with a single header file, because indeed, you see what I get. This is what you get if you don't disable testing. So there's a test executable for absolutely every single test case. Awesome. Yeah, that's called C-test for you. I prefer Google Test, which gives you all your tests in one executable file, and integrates with the test Explorer in Visual Studio as well. But anyways, okay, so I don't know if there's, like I said, there's nothing really that I need to actually compile for this. These are literally just a whole bunch of tests. This is a header-only library, so great. We have a CMake file for this. It's literally just for test files. Okay, so let's just close that. I'm fairly certain it compiles. All right, so let's just take the, according to the documentation, I believe it was in the nolm files, so nolm and then json.hpp. I think there's also a, here, single include. I think we need this one. So there's actually two files here. JSON.hpp, which you can see is nearly a megabyte. So we don't want to include that in too many header files, but there's already also a for declaration file, which is only 7K, so considerably smaller. And this is generally what you probably need in most cases. And then JSON.hpp only in the CPP files where you're actually going to compile code for it. So let's take these two folders. Actually, we'll just take this one, and I will put it in my serialization folder here. And what I usually like to do is just let's make this a bit bigger too here. I don't know if you can see it or not, but anyways, the Visual Studio folder, so pretty standard files there. But I like to have a folder called extern for external libraries. And then I'm just going to put that there for nlohmann, whatever. I'm not even trying, whatever. Stop trying. Okay, so now we have it there. We need to tell our serialization library where the files are. And since it's only a header file, we just basically need to tell Visual C++ configuration settings here where the include directory is. So from here, we have it in extern. By the way, all these paths are going to be relative to the project file, project, not the solution necessarily, unless you do something like, I don't know, some people like to do this solution-dir, which I think is redonkulous. Just always make sure it's relative to the project file and you're good. So that should be, what was it called? nlohmann. Oh my gosh. All right, so oops, that was not the file button I wanted to press. But what we can do is just right-click on something here and say, if we had a header file here, and say copy as path, because whatever, I just don't want to know how to spell things. I just copy paste, and then paste that, and then we're going to get rid of all the folders. Oh, I didn't write. Yeah, I'm just dumb. Okay, I'm just dumb. What we just want is extern, actually. Okay, that's cool. We just wanted extern. I think that's fine the way we just do that. We don't need to really put a thing on there. I think it's fine like this. Okay, good. Extern, and then what else do we need? Nothing, because it's only a header file. All right, then we'll see if we can include this nh something yom frack. Still on my clipboard, so whatever, let's do that. So it should be this and json.hpp. It should be that. Now, if I can do this, I'm going to actually change that from a backslash to a forward slash. And then if we hit F12 on this and it finds the file, well, then we know we've set it up correctly because, hey, the file got found. All right, so I'm going to do this. I'm going to keep this on the file on the screen on the left, and we'll keep my source code here on the right. And I'm going to do something pretty simple here. I'm going to create a class which I can serialize. Just quickly looking at some of the examples. It has standard serialization for standard template library types. But let's see where it is. Iterator, I had no idea what he's talking about there. But anyways, STL like access, conversion from STL containers, yada, 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 bunch of blah, 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 JSON, JSON, implicit conversions. Yeah, we can just make a person class like this here. Okay, so let's do that. Again, namespaces are absolutely not required in all cases, right? So we can just do without namespaces. So let's just create a struct, or even better, a class, because very likely you guys want to make classes and not structs. But who knows? And let's create some of the data as private, because what I want to show you is how to actually create a serialization library for this without exposing all the members, because most likely you want to maybe serialize something that might actually have private data in it. I don't know. Let's do one step at a time. We'll do public first. I don't want to jump right into like the advanced features yet. So, okay, well, we need a string type, so let's include string. String. Okay, so std string, name, obviously. I mean, this is not a very good example because it's, just basing it on theirs. And I don't care about address. I just want name and age. Okay, and of course, we can have constructors for this. Oh yeah, that was actually a requirement for serialization later, that default constructible. So all your serializable types for JSON for this must be default constructible. I'm not sure that's a requirement for all types, but for JSON, for all types in serialization libraries, I mean, but for this library, it says they must be default constructible. And we can also have a one that allows us to construct it from parameters const string name and int, obviously, age. Okay, so this compiler is smart enough to know which one is which, and then when I do it like this, and no body. Okay, now he's giving me squiggly about something. Pass by value and use std move. Yeah, forget it. All right, so now we want to be able to serialize this type to a class. So let's first of all create a person type, me, Jeremiah, and I'm afraid to say it, but 45. And then we want to do something like this, right? We want to have this JSON type. I don't know, is there a namespace for these guys? I don't know. Probably, yeah, there is. So we need to specify null. I don't really want to do that. So I'm just gonna, I'm not saying you should do this in header files, but in CPP files, you can do this using namespace nlohmann. Like what is that? And now we don't have to type the whole namespace anymore. Right, and then, yeah, this is the simple way, but not really going to be the name or the way that you are generally using this. Actually, oh no, forget it, doesn't matter. But you generally want something that is going to be automatically serializable. So that's the next thing I'll do later. So we don't have to actually do this kind of wacky stuff right in the middle of our code. We just want to be able to serialize it in one go. We'll see that in a second. Okay, so in order to get this to disk, from what I saw from some of the examples, is that we need a file stream. So let's pull in. Let's pull in. I don't know if these are separated. F stream. I don't know. Is there an OF stream header? No. Okay, so it's just F stream. But F stream is just file stream, so we can maybe pull up that in this on the sidebar here. C++. This is C++.com. CP reference is my preferred reference documentation for C++. So I think that the F stream has both file buffers. We don't need to know that stuff. But anyways, F is input and output streams, but F stream is input streams. OF streams are output streams, obviously. These are for wide character variants. Well, if we want to support wide character variants, I guess we can use those. We also have the F stream, which I think is derived from both input and output streams, so we can do both operations. And where is the documentation for F stream? No, okay, never mind. It's basic F stream. Right, so as you can see here, basic F stream derives from IO stream, which derives from both input stream and output stream, which is basic input output system or something, and iOS basic input output system base. But anyways, the point is that it's derived from both input and output streams. And F stream is specifically for files. All right, so we really want to use F stream, I think, or actually for output, maybe we want OF stream, but it doesn't matter. Doesn't matter. Let's just use that. So F stream, and we'll just call it F, and then we need to give it a name. And since it's a JSON file, we want a JSON extension, very likely, right? So we do something like that. I don't have to specify read-write flags, I think, but I could specify std out, for example. But if we don't, I think by default it will be text. We don't specify binary, but we could, for example, do, it's going to be iOS, I think, iOS out and std iOS binary are the other options. But since we don't want a binary file, we just want out only. Somebody is at the door. I don't know why. I'll be right back, just in case. I'm going to pause this for a second. All right, sorry, I had to stop the stream there for a second. But anyway, so we're going to be doing output, so we want to create a file stream with output capabilities. And I'm pretty sure the stream operators just work with this. So if we go F and then we output the J, and that's it. I'm pretty sure that's it. That's how we can write this JSON file to disk. And okay, so let's run it and see what happens. Okay, so I didn't get any errors. It just basically said it will, it'll close whenever you press any button. So let's see if we actually got a file on disk. So let's go back to the root folder here. So Jeremiah.json, let's see what this looks like. Age 45, name Jeremiah. So it actually worked. Okay, good. Applause. Wait. Where's the applause button? I have it here somewhere. Golf clap. Yes, thank you. Thank you very much. All right, let's go back to the code. Okay, but this is kind of cumbersome, right? We don't want to have to write this every single time. So one thing that we saw in on the tutorial on GitHub here on the README is that we could use these functions to automatically like parse things. And let's see how this works. So we need a function called toJSON. So let's first create that, toJSON. So this will take our person class and convert it to a JSON file. So we take a non-const reference. And again, if we haven't imported the namespace nlohmann, we need to prepend the type with the namespace. But since we have it here in our local scope, then we don't need it here. And a non-mutable person, a reference to a person, P. Okay, so easy enough, easy enough. And then we just going to specify that the J is, apparently we can just do this, or since it already contains that person, but okay, it looks like we can construct this from as many arguments as we want. So initializer list, type deduction, okay, whatever. Let's just see what happens with this. So we'll actually format this in a way that looks JSON-y as well. So then we have name, and unfortunately we don't use, in JSON it would look like this, right? But here we have to use p.name. And then we also have, what was it, age, p.age. Okay, and there's our serializer. Now this is pretty simple because generally what happens, what if I suddenly want to add a new field here and I want to, address, and then I want to add that field here. Well, if I do this, I can totally do this, right? Because that's possible, but any file that was previously serialized without address won't have the address field in it. So I'm not sure how that gets handled, but we'll take a look at that perhaps later. What we need to do there is to handle versioning of the JSON file. So what we can usually do is we should do that. Any serializable type, serializable type should have a version. Actually, maybe even, so no, let me think. Yeah, static const int. Actually, static const, can we make this inline? I think we can as a const expression, but let's initialize it to 1. And anytime okay, he's going to give me a hint here as to const expression. Sure, I mean, I'm only really using it once. And to be honest, I don't know can I do this in a header file? Sure, I can. Let's do it. Yeah, it just needs storage somewhere, but maybe if I do it like this, it doesn't need storage anymore. I don't know. But anyways, the first thing that we should do when we write the thing to the file is write the version number. And the reason why we do this, and you'll see this in a second, is because when we are serializing something, we want to make sure that we are serializing and deserializing correctly. So we shouldn't necessarily need to handle version numbers unless, oh no, we don't have to, because every time we write the file, we always write it in the latest version. But whenever we read it, we need to be able to figure out which version it was when we actually serialized the file, if we want to handle updating of our serialized files. Make the name variable parent. I do not understand. Make the name variable parent. I'm not sure what that means. Anyways, if somebody can decode that for me, then I can maybe do something like that with that. But let's take a look at this. Okay, so we have it serialized out, but instead of doing this stuff, I want to do something like, let's see how we can do this now. Oh, we just have to do assignment. Okay, sure. And then we'll just say me, oops, and we'll get rid of this stuff because now it should know how to convert me to a JSON object. Yeah, it's not being modified or mutated, so sure, it can be made const. Yeah, okay, I get it. I'm not entirely sure how this crazy stuff works, but apparently there's some template magic going on here to make this work. But let's see if now I've actually added this to JSON function. Let's see if whenever I want to serialize an object of type person, I just have to do it like this. And you know what I'm going to do? I'm going to actually add this serialized file. Let's add that file. Let's add an existing item so I can inspect it easier. And we just put that in there. Okay, so it looks like this now. shouldn't actually try to compile it or anything. And if we just run again, okay, we didn't get any errors, nothing, everything worked perfectly. And if we inspect the file, then we see we now have the version number and we have name Jeremiah age 45. Now it's a bit weird how it got serialized because now you can see that it changed. It's now a list. So that's a bit weird. I did not expect that. But now it's a list with a name. Let's see how this works on deserializing. All right, so we'll do this like this, and we'll create a scope block here because now what I'm doing here is now I just create a scope. And now if I recreate scope here, so all these things will, at the end of this curly brace here, they will all actually unwind and they will, like the stream will close and whatnot. And then I can try to read the file in. So this is just serialize data to a file and deserialize data from a file. Yeah. So in order to do the deserialization, we need to provide a function which does that. So then we check void from JSON, which again probably just takes JSON const. Actually, it's not. Yeah, const because it's non-mutated. JSON objects in this case, J and a non-const, so mutable person. And this is the reason why it needs to be default constructed, because before it is deserialized, JSON doesn't know how to construct the object, so that's why it requires a default construction. Okay, I'm getting a notification that I need to take my garbage out, so I'll do that later. So, okay, there's a few ways it looks like I've seen in the documentation that you can actually get values. It looks like get to, they take, you have overloads for every type that they can serialize, I guess, so, or deserialize, I should say. So then we're just going to use the same method here at, well, first we're going to read the version number, and we should have an int version equals 0. And then we'll say get at, and then just use the version number here. So what am I doing wrong? Oh, get to, yeah, of course, get to. And now we know which version the file contains, or at least we should know. And we can use this later. Right now, I'm not going to use any of it because I know that in the initial version at version 1, well, I can do this if version is greater than 0, because I shouldn't have any data at 0 because it started at 1. So I can do that, right? Then we parse our version 1, 2, 3. Actually, because I'm thinking sometimes you want to remove fields. So if it's greater than 0, then it might have been that some fields were removed. So I have to be careful about that. But we can handle that separately, I guess. At name.get to, and then p.name, and j.at age.get to p.age. Okay. So now we have a serializer and a deserializer for our person class or your saved data structure or whatever. And now let's try to read it from a file. So for that, we probably just need, well, another F stream. Well, we can specifically use an input stream, but whatever. Jeremiah.json and std ios in to specify that we are going to be reading data in. And then we just go, oh wait, I guess we just still need to have a JSON object. So let's create that. Yeah, sure. And then F, and then we're going to read it into there. And then we are going to print it to the screen. Sure, why not? And just see out J name. I will say something cool like hello J name. Yeah, period. Of course, I need another chevron. And you are age years old. Years old. Just to make sure that everything went right. Okay, doesn't like this. I did this wrong, of course. Can't believe there's like 10 people like, there's everyone's in the quotes. Okay. Does that look good now? I mean, it's getting a little bit off screen here, so let's move this around a bit. So I'm hoping this works because now it changed it from like an object structure into a list, which is weird. But okay, let's see what happens. So now if we compile this, it should compile no problem. And we can run it. And we get an exception thrown. So yeah, that's interesting. Unhandled exception, type error at memory location. So what do? We go on the call stack and go, okay, well, what were we doing at that moment in time? He was trying to output the name and he didn't like it. Oh, no, wait, it's going to try to run this. Let's see if fstream didn't contain any valid data. So did I type something wrong? Or did I do something wrong? Let's see. Jeremiah.json. I don't see anything wrong with this. I don't necessarily see anything wrong with this, but okay. Let's see what f contains. It definitely didn't like this. It doesn't look like the file is set up correctly. Everything seems to be null. So I didn't really have fun opening it. Let's see if there was any error. No, there was no output error. It basically just comes back. I should check for an error code, I guess. Okay, I'm doing something wrong. Let's see what the documentation says about this. What's this? Boost none. Partial specialization, full specialization. To JSON. Write my own serializer. I might be missing something here. Let me just go up quickly to the part where just before they do this, here we have a person, conversion from person to JSON, cout JSON. Convert JSON, copy each value from JSON object. Basic usage. To make this work with one of the types. JSON, okay, so it doesn't actually show how you're doing this, how they're doing the serialization part, but or deserialization, I should say. So I might be making some hello. Okay, my headset also decided to die, even though it's at 92% battery. Wait a second. Make the name variable parent. I'm talking about this. Oh, so the top level object is Jeremiah, age 45. It became a list because you serialized everything on the same initializer list instead of version, person version, name, name. But that's what I assumed that the serialized version would do, right? So with the object that you get during toJSON is already a nested object, or it should be, or I need to do something like this. I think this is what you mean. So I do this. Feel free to turn your microphones on if you want to make comments or typing in the chat. Look at the example above. Okay, the example above. Right, but okay, so instead of the curly brace, this is what they're doing, right? So in the to JSON in the example here, they're doing this. The only difference is they use curly braces for the constructor instead of parentheses. But it's no different, right? So it's parentheses to construct the object. It's called an initializer list or initializer. But then this is a object to, okay, I see maybe what you mean. Yeah. So this is probably an initializer list, not an initializer, constructor initializer. No, every field is separated. Oh, yeah, you're right. Okay, annoying, but okay. Then it should look like this. Maybe that's one. Yeah, okay, sure. And then like this. Right? Is that what you mean? A parent or something? Yeah, okay. And then I have too many braces. Let's see how that gets pre-printed. Okay, something like that, I guess. Yeah, so indeed, this is starting, I guess, an initializer list, and these are all the name value pairs. Yeah, it's a bit weird. And then I shouldn't have to do this anymore. I should be able to just do that, and then I should still get a single object in the file, which is what I want. So let's. Still don't know why I wasn't able to open this. Do I have to explicitly close the file stream before it actually gets written again? Okay, so it should have at this point rewritten the object, which indeed, yeah, now it's wrapping the. Yeah, now it's correct, right? So now it's age colon and then the value pair, name value pair, and then the different fields separated by commas. Okay, so that's what I would expect in the JSON file. Yes, happy now? Is it working? Okay. All right, so for the input file, let's see if there's anything here. If anything got changed here. Now it doesn't look like it's really. Oh, wait, F still looks like it's null, but okay, I guess it's a valid object. Maybe I shouldn't look at this pfee zvt whatever it was. Yeah, it didn't segfault this time, so I guess he's okay with it. And now J has, yeah, indeed 3 name value pairs. Yeah, I don't know what the underlying information looks like here. String, binary. Okay, whatever. I'll just leave that, but let's see if the correct output gets printed to the console here. Here we have, hello, Jeremiah. Oh, it kept the quotes. Annoying. Okay, but whatever. We can see it's working. You are 45 years old. Okay, so strings actually have the quotes in them. That's a bit weird. I wouldn't expect that, but okay. Okay, be aware. The names actually contain the quotes. All right. Well, I was doing it right, but most part, except for I missed a few braces in here, and the deserializer seemed to have been already working correctly. But let's say, for example, now we add something to our person field, and we don't reserialize. We're actually going to deserialize, and we're going to swap this around. Or not swap around. We're just going to serialize it to disk again, but we'll just leave this part out because we want to see what happens if we try to load with a different version. And then we're going to call this, I don't know, output file. And then we're going to also make, I don't know if I can use the same thing for input and output, but probably. You know what? Let's just try. Let's just call this F. It's going to append probably. Will it append? Yeah, I don't want it to append. So I'm going to do this. And then we'll just make a new one. Scope. And then we'll do the exact same thing we did before, which is going to serialize it out again, but then with a new version. Oh no, I need the JSON object. So let's bring that out here. Because we need that. We're going to deserialize it, then we're going to serialize it. f, again, jeremiah.json. Actually, you know what? Let's call it v2. Out. And then we have the JSON object already, so we're just going to go like so. We don't need to do anything weird. Okay, so now what we're going to do is we're going to add some data to this. We're going to add the address field. And now we're going to bump the version because now we have a new version, and we need to check which version we're serializing. And if version is greater than 1, then we can also at address, oh, come on, dot get to p.address. Now, if you didn't have public methods for everything, you could still do this. I think there's a way you can actually write the serialization functions directly on the class itself. Maybe you have to specify, I don't know. It doesn't show an example of actually extending a class for serialization. So, but if these weren't public, you couldn't access them directly. You'd have to use temporary variables and getters and setters and whatnot. Or, yeah, like I said, or implement a to JSON file or from JSON functions on the person object. But I didn't really spend much time to figure out how to do that correctly. Okay, and of course, anytime we serialize, we have to also add the address. p.address. Okay, so now we've added additional data. We bumped the version number. And even if we try to load an older file, it should still work. And then we serialize it out. Right, so I'm going to put a breakpoint here in the from JSON. And we're going to make sure that it's actually running correctly. So the file should still be at, we look at this, we should still be at version 1. I think I had still something open there. It should have hit a breakpoint there. Did I get a compiler error or something? No. No? Oh, maybe I'm doing this wrong. Hold on. From JSON. Yeah, this should get triggered here. Right? Why didn't it? Still version 1. Did I get an exception again? No? Let's see what's happening in the console. Well, absolutely nothing. Oops. I'm going to step over. Hello, Jeremiah. You are 45 years old. All right, because it's a different file now. Okay. Of course. Because I'm an idiot. And I decided to use a different file. So let's not do that. I just want to make sure that, whatever. I'm just going to do it again. Okay. But why this breakpoint didn't get hit? I find that very weird. I mean, these should be throwing in order to deserialize the object. Oh, but wait. Oh, good. No, I don't know. Well, whatever. This should have actually happened. No, I'm not sure why. It seems to work though, but I'm not sure why the two JSON files not being. I'm not doing field by field deserialization, so it should have done it. Okay, but anyways, and it should have definitely. Did I spell it wrong again? Jeremiah. Okay, doi. We read it from disk, and here we serialize it out again. Jeremiah output. That should be. Should definitely have overwritten the file. And this object should definitely be the new. Oh, wait, because I'm an idiot. Yeah, I'm an idiot. I'm a freaking idiot. I know why I didn't do it. Because I'm an idiot. I didn't actually create a person. I'm only loading the JSON object, but I didn't actually, I only loaded it to the JSON object. I didn't actually create a person. So we read it in, but then we still have to convert it to the person. So for that, we have to do something like person p. How do we do this? J dot. Well, I wish it would have shown an example of that. Because do I just? Oh yeah, j dot get. I guess we can just do this. J dot get person. What was it? Person? J dot get person. Doi? Something like that, right? Okay, so now we have that person, and we will go person p. Let's do that, and we won't redefine it, but we'll do this. And now we need to also specify that the person should be serialized again to the JSON object. So J is equal to P. I guess that works. Serialize. Yeah, doi guys. Okay, so that's why I never called the deserializer, because I was only dealing with it in its JSON format. I didn't actually try to convert it to a person. All right, so let's see if that works. Okay, so now we get an unresolved external symbol, but that's probably because I defined a default constructor, but never actually. Yeah, with default, but I didn't actually define it. Default. Doi. Okay, yeah, I know there's a lot more default constructors I can use. Okay, so this should never have changed. No, that didn't change because we didn't actually do anything with a person. So now let's try this again. Okay, that's serializing. Oh, we doi. What is it complaining about now? Parse error. Parse error. Why are you getting a parse error now all of a sudden? I certainly didn't change anything with this file. But what am I doing wrong? It's not even getting there. It doesn't even hit the toJSON object or from JSON. Doesn't even get in here. So he's just like, I don't know how to deal with you, man. Okay, let's try this again. Okay. So, all right, he's already like, no, don't want to do this. Okay, what's he complaining about now? Unhandled exception. What's our call stack? What line? Well, we read in the file. We were about to read in the file, but he doesn't like the file format for some reason. All of a sudden, all I did was add a person. So I'm not sure why this would cause a problem because that's all we added. Any indication why you don't like this file? All of a sudden. I'm pretty sure we didn't change anything. So what is wrong with it? It didn't even get to the toJSON object or from JSON. Didn't even get there. Class and JSON doesn't same. Class and JSON. Maybe the file got corrupted. Well, I'm not sure. I mean, I can still view it here. Sure. There was a v2 file, which wasn't actually v2, but indeed it got emptied for some dumb reason. That would be probably why it's not a valid JSON file anymore. which is why Visual Studio is giving me bunk information. Yeah, see, it was empty. JSON, age, name, address, class name, address, age. I don't think that matters. No, the order doesn't matter. Class and JSON doesn't matter. No, the order in the JSON file doesn't matter because it will build a JSON file from it, and it should know how to parse these different fields, unless there's a typo in some of these fields that, like for example, only in version 1 that field should exist, and only age. So I think it had something to do with this. Can I do that? Maybe, I don't know if this, what happens to this after I assign a value to it post construction. So let's do something like this. Yeah, we'll add this back again just to get that file back into its correct state. Oops. And we'll see, let's just run this one first. And I find Notepad++ more reliable because it actually updates the file if it changes on disk. Okay. Yep. Reload it. Okay. I guess I have to go out of scope first. Okay, so there it is. Also contains a version bump and empty address field, which is fine. It should be fine. Doesn't need to actually have data in it. So let's read the person in again. Okay, now the JSON object should be able, there we go. Now it's entering this version. I don't know why it got corrupt or why, maybe because, I don't know. But yeah, now we get version 2. So now we know we can parse the address field. Step, step, step. This is not an exception. This is just stack trace. Hello and whatever. This should be working now again. Okay, now we're going to try to serialize again. Same output file. And then we'll just assign P to, it should, Did I miss the version? No? Wait. Oh, by the way, did you guys know that if you want to try something again, you can just go like this? Okay, so it is going in here, right? So this should contain, oh, that's the person. Geez, I should be looking at this. Okay, anyways, I think it contains the version information. This was just a place to put a breakpoint. All right, and then we reload that. Yeah, nothing changed. Okay, great. Okay, it was working. I don't know why the file got emptied, but that was the reason for the exception. The file was just empty. Okay, but anyways, my example of, bumping a version number to, parse data separately based on the version of the structure. Yeah, I think you get the point. It's probably always a good idea to have a version, static version number, because it doesn't necessarily need to take space in the struct at runtime, but it should definitely be serialized to your file for any class type that might actually change between save file formats. Any questions about that at this point, or I don't know. Okay. Another great lesson: when you deal with file input output, handle errors gracefully. Yeah. Sure. If I had more time, it wasn't like in a in a recorded session, I might spend more time doing error handling. For sure, but for this thing, yeah, you should check for this, see if the file is correct. Okay. The thing is, there was nothing wrong. So even with the file empty, if we delete the contents of the JSON file, the F stream is fine with it, right? Because he's just like, well, yeah, I'm pretty sure you meant, let's skip this part here. I'm meant to be done here. So let's say this file was empty. Should still be empty at this point. Yeah, empty. And even if we open an fstream, and there's nothing wrong with the file. It's just an empty file, but it's how JSON actually tried to handle it. And even if it looks like I'm not sure I could actually have caught this exception, or maybe I could have, I don't know. Maybe I could have. But yeah, he's just like, I'm not going to parse an empty file. No way, man. And he's not going to provide defaults. So anytime you try to read a field that might not be in that JSON object, yeah, you'll probably run into problems. So not the file handling that's a problem, it's the JSON parser that was problematic. So yeah, I could wrap that, I guess. I would probably need to wrap, well, in this case, I needed to wrap this part in the try catch block. All right, so that's what this would look like. And we just catch, I don't know what kind of exceptions there are in JSON, but I'm pretty sure they're going to be derived from std exception. So we usually do it like this by reference. And then we do something here. Faultable. All right, so for some of you foreigners out there, that just means bad stuff. In Dutch, that's my best Dutch. Something went wrong. Okay, so let's see if I can trigger this to occur. This is input, yeah. Oh, it didn't cause a problem because we did this part already. Let's do that again. Yeah, reload. Okay, we have a bad file. Audible. Let's see if we can catch this. Yeah, we caught it in this case. So whatever exception it was, I don't know, std JSON exceptions, whatever. Very likely it's derived from std exception, and we can catch them in this way. And then we have faultable. And this will fail as well, probably. Yep, you didn't like that. Type error. Cannot use with blah. Okay, so it fails on reading it, but then it also fails when you try to parse it, or it fails here to parse it, and then it tries you try to get it, and it's also going to fail there. Okay, so we should actually do all of this here. Right, okay, so this is an exception safe program now, I guess. I mean, you might want to figure out what to do when this happens, but in most cases we just catch it, throw an error message out to the user, and say faultable, error code 8004400599059, and then don't continue. Okay, but serializing the file again would, okay, this is uninitialized data because we didn't deserialize it, so chaos ensues. Chaos ensues. In this case, we need to reinitialize our data structures, but whatever. Okay, another great lesson. Okay, so it's nice that you got caught on the recording if peak equals end of stream error. Okay, fair enough. Sure. So this is the mathobserver is suggesting that we do something like this. If handle empty file. So let's just put that something like that. Not a file, sucker. Totally random and off the top of my head. And let's see if this catches it if I empty the file and don't serialize it to a disk. Serialize it. Let's get rid of this. Empty the file. Run the code. What does it say? I can't convert this to EOF. Yeah, okay, so this is not giving, something is not coming out right here. Non-standard syntax, use ampersand to create a pointer to member. Point. Oh, I think you mean iOS. That's very likely what you meant. Okay, so that's fine. Probably. Yeah, not so much. Type traits. Okay, if you say so. Okay. Wait, yeah. Type traits. Traits type. Okay, this seems very verbose and okay, well, at least it compiles, and indeed it caught the end of file. But I'm not sure this is the best way to do it. But we can check the reference later. But there are better ways. I mean, let's see if you were looking at, for example, because this might be interesting for this one. If we have file system, and I think we are going to have to upgrade to 17. So for that, we go to general and we set our standard language standard to 17 at least for file system. And then we can do things like, well, I don't want to have to type std file system using names using fs equals to std file system namespace alias. Do I have to do this namespace? It's been a while since I did this namespace aliasing. Well, whatever. Help me out here. Who can do a namespace alias? I forget. I know it can't be used as a type. No? Nobody knows? Okay, forget it. I'll just type it out. I can't remember exactly how to do the namespace alias. So for example, I would do something like this. But this might not necessarily catch it, but okay, just namespace, not using. Namespace, no. So what is the green line says? Namespace alias f is unused. Okay, it's unused. Well, okay, I'm going to use it in a second here. So then we go file system path. Yeah, file, whatever. And then jeremiah.json. So now with path, we have a bunch of things we can use. So we can say, for example, if fs is a regular file. Sorry. Actually, first we check if it exists. First we check if it exists and is a regular file, because that's, you don't want to actually try to open a directory for reading. And fs, I think there was a way to get the size. File size is greater than 0. So if all those things are true, file is likely correct. Hello? Okay. My headset just feels like turning off on its own every once in a while. Right? So then it shouldn't be empty. Else, not a file. Something like this. So, and then, well, whatever, return error code. I know multiple return statements are probably not a good idea. Should return value. Okay, return -1. Whatever you say. Anyway, so then in this case, we shouldn't have to check for that anymore. But yeah, parse errors we should probably still try to handle. Yeah. I don't know. Int I equals 3. I don't want to really write anything here. I just want to put a breakpoint, see if this actually gets in here. Well, we still have an empty file. So we should get not a file sucker. Indeed, we got not a file sucker. Oh, you can't see this because it's on a breakpoint. I don't know. But anyways, not a file sucker. And if we then write the file, oh, damn. First, then I hit this breakpoint because it exists. It's a regular file and it has a size of greater than 0. So those are all good. And now we can do the serialize. It's deserializing. So I kind of prefer to use path, file system path, to check, if the file is kind of good. And then we have to rely on parsing errors to make sure that the file is actually, parsable. And all this stuff with file system type trace and stuff like that is, I don't know if that would be my go-to. This is really, self-documenting code, kind of. The other stuff is like EOF. Okay, up to you, right? Try to be unopinionated. Yeah. Couldn't find your save file and you realize that you lost a few hundred hours of progress. Yeah, exactly. Exactly. Yeah. Your file's corrupt or somehow got moved or isn't where you expect it to be, or I don't know what happens to files nowadays. But anyways, so that's an hour in, and are there any questions about that? I do kind of want to just look at Serial for a bit. If it's anything like the Boost serialization library, then I actually kind of prefer it, but I don't want to go into too much details about it. But what I do want to say is that, for example, it handles multiple file types. So Serial can be used for binary serialization, XML file formats, which might be handy in some cases, or JSON out of the box. Now, of course, you can implement your own archivers so that you can actually do any file format kind of thing you want. If you want to use YAML or whatever, then you can do that. You can have a different parsers. You can implement your own, I guess. It might be kind of laborious because you have to provide serialization functions for all possible STD container types that you might want to handle. So that might be a little bit, not ideal. Rapid JSON is another one, but again, you're stuck with JSON. And if you're fine with text formats like JSON, I think JSON has a binary format. I'm not entirely sure how to handle JSON binary formats with this one, but I'm pretty sure I saw somewhere in the documentation that it can handle them. But in the end, you're like, okay, well, I don't want, text readable, or even I don't want to deal with JSON crap. Then maybe you can actually, just look. There are different serializers. That's all. That's the bottom line. YAML's cool. It's actually what Unity uses in its file format. YAML stands for, I thought it was yet another markup language, but YAML ain't a markup language. Okay. But this entire file is a YAML file. Yeah, it's a bit weird. But it kind of is a superset or subset of JSON, but it's much more succinct, meaning that there's not as much textual fluff. Because JSON has these, curly braces and quotes for strings and whatnot, yada yada, and it's a lot of extra stuff. But YAML has the same format, right? So it's the like the name and then colon whatever, and then indentation for nesting, and like this is a list, for example. There's different things. Yeah, there's some more functionality. Yeah, well, I don't want to get into that too much, but just know that there's many more serialization formats that you can have. Okay, so serial, so the nice thing about serial is that you don't really have to know necessarily what kind of format the archiver is going to produce, because the serialization functions of your class just deal with archive. Now, as far as I can tell, this is used by both input and output archives. So you don't have different functions you don't need, you can have, of course, but you don't need different functions to convert to JSON and from JSON. And you can still have version handling, but version handling, I believe, is handled a little bit differently in Serial than it is in JSON. I mean, we had to explicitly add versioning to our classes in order to handle it properly for changing of the structures. But I think in Serial, if it's similar to Boost versioning, then it's kind of handled automatically. You just have to have a special member variable for the version of your class and make sure that it's serialized first or something like that. I don't exactly remember how it works, but yeah, obviously there's going to be full support for standard library types. Since it's based on Boost, yeah, you might have your code already in Boost, and it might be nicer to do this in Serial. It handles pointers and references. JSON does not, right? So you have to patch up pointers. If you have a pointer in your class to another structure or something like that, then you have to do that patching yourself, which I'm not even sure the recommended way of handling that. Maybe with universal unique identifiers or something weird, but Serial, I think, does that out of the box, basically. Yeah. Yeah, and so anytime it encounters the same pointer address, it won't reserialize it. It will just, make links to the original. Yeah, so there's a bunch of stuff here. I kind of wanted to see the different ways of serializing a class. But yeah, if you have third-party types that you need to serialize, you can do that too, of course, because you can't adjust the classes, so you have to make them serializable. Outputting using serial built-in support. So this looks like a JSON format as well, a list of objects. But anyways, okay, so there's definitely some different options there. The channel has a video of game serialization using YAML CPP, actually multiple since he uses it for his engine. YAML's a bit hard to read sometimes, and a space code doesn't works. And what? And a space code doesn't work? Is it mean code with spaces, or like you can't have spaces in the variable names, for example? Yeah, so if you're parsing this to an object in C++, yeah, they probably won't have spaces in the names, if that's what he means. Reference is a problem I faced when doing serialization in my engine. I needed to store a reference to the active scene, and JSON doesn't support that. Yeah. Okay. So any questions about that?
No, just the error part was a bit weird for a beginner like me.
The exceptions.
Yeah.
Yeah.
But other than that, it was fine, I think.
Yeah, getting exceptions is never fun. And I mean, live coding, always a huge risk, running into errors, but I don't know, I think we fixed them pretty quick. It helps, if you guys type stuff in the chat, and it can pick up these things like the fact that I was doing this wrong, which I did not pick up just by reading the documentation. I just glazed over it. What was that? I think, was it Matt Muser who caught that? Useber?
It was
Ballads.
Matthias, or never mind.
I think they both did.
Yeah, I think they both did.
Yeah. It's like when two people invent something, in different places, and the first one to the patent office gets credit. Something like that. Okay. So I'm going to do a quick sign off, I guess. Yeah. So if you got up to this point, I commemorate you on your patience and ability to listen to long videos and presentations. And don't forget to like and subscribe. And thanks for watching, and I'll check you next time. Bye.